Welcome everyone and welcome to my presentation about a comparative evaluation of EduClust and its transfer to a virtual reality environment. And before we go into the details of the paper, I first want to start with a really brief motivation why we think pursuing such a nice pedagogical software like EduClust is really worthwhile pursuing. And that's why, first of all, I want to take you on a trip through history. So hopefully you can see the slide. Yeah, so here you can see this is basically a snapshot taken from a classroom setting in 1903. And what you can notice here is that we have a professor or a lecturer in front of the students, and he is really reading from a book. So no media is involved here. And we have many students, unfortunately only male students, and they have just a tiny space to take some notes or to put on their papers or whatever. So over the years, of course, things changed. So for example, here a new picture taken in 1968. So you can see now female were also allowed to study. So this is a really nice thing which happened. And what you can also see is that the students are granted some more space. Okay, so now they're really able to open up their folders. They easily can take notes and so on and so forth. So if you are now looking at our current lectures, so how they look like, many things have changed. So here you can see we have, of course, in front our lecturer or professor. And what he has access to a projector. So he can easily show his slide set. He can easily show some videos or even audio files and so on and so forth. But what's even more important, if we have a look at the students, so they are pretty well equipped. So you can see all of them, they have access to laptop devices or tablet devices or mobile phones. And of course, that's the idea, to somehow, get these computers and to somehow increase the engagement of the students using these computer devices. So what's the current state of the art? And therefore, I want to take you to the University of Constance. So what are we doing in our lectures? How do we try to enhance the engagement of the students and to facilitate learning? And if we have a look at our lecture about data mining, for example, it looks like pretty much the same as the slide before. So we have our presenter at the very front. He has access to slides, of course, and we have all the students and they can take notes with their laptop devices. And if we now want to have a closer look at the slides and see what we can do here. So the idea is to teach clustering algorithms in this specific lecture here. And what we can do is we can make use of PowerPoint's cool features to implement animation, for example, to show the algorithmic behavior. So in this case, you can see the k-means algorithm. We have two centroids. These are these yellow circles, and the red circles are just the data points. And what we can do is, with the animation concept from PowerPoint, we can just show how this algorithm works. So first of all, we are partitioning the data space. Then we are assigning data points to the centroids, and we are moving the centroids to their new location, which is the average value of all assigned data points. And since it's an iterative process, we are just repeating those steps. So now again, we are partitioning the data space, we are moving the centroids, and so on and so forth. And this continues till we reach our final state. And this works pretty well. So people and students understand the concept of this clustering algorithm. However, the problem is if we have some motivated students and they ask questions. So for example, what happens if I include another centroid? Or what would happen if I have a slightly different data distribution? And now it's getting difficult because in PowerPoint, I cannot this easily change the animation and introduce a new data point. This doesn't work this way. But what I can do is basically I can go to the blackboard and then I can take some drawings and show what would happen if I introduce a new K or whatever. So I can easily adapt to this question. However, of course, this doesn't scale this well. So for example, if there are many questions and they have really a more complex theme, like for example, having multiple cluster centroids, having different data distributions, of course, I cannot draw everything. This doesn't work this way. So it doesn't scale. So what else can we make use of? And the cool thing is that lots of universities, they already try to tackle this problem to make things a little bit more easier to access. And here you can see this is an implementation from the University of Stanford, and they implemented an online version of this specific clustering algorithm here. And you can just run this algorithm and see how the different steps look like. So assigning basically these data points to the cluster centroids, then moving those cluster centroids till we reach a final state. And this is pretty cool. So we can easily show these animations and we do not have to create our own in PowerPoint. But again, the problem is, what happens if we have some students asking questions? Since these online tools, they are really, more or less hard-coded, so we cannot easily change input parameters, we cannot easily change data sets, so it's really difficult to answer those questions if they are really specific. And that was basically our idea with our EduClust software, so we want to tackle exactly this problem to be a little bit more flexible. And what we did is, we first of all asked many different lecturers teaching data mining, so what visualization techniques do you use in order to teach the one or the other clustering algorithm? So we collected all this information, and as you can see in our paper, we are not claiming any visual contributions, but we're making use of things already established. And most people say, okay, for teaching k-means algorithm, we are using scatterplots, for example. And of course, that's why we are also using scatterplots. So our EduClust software looks pretty much the same as the tool from the Stanford University. And we can also run just the algorithm, in this case, the k-means algorithm, with 3 cluster centroids. And data points are moving, data points are assigned to the centroids, and so on and so forth. So this was basically standard. But then we are putting some more features on top of this one. So for example, it's pretty simple for our students to also change some input parameters. So to adapt to a different cluster number, for example. Then we can change the distance measures. We can go through the algorithm stepwise. And this is pretty cool. So we can really slowly experience how the algorithm evolves over time. And the last cool feature, that on the right-hand side, we have a pseudocode. And this pseudocode is linked to the current step. So you can see some things are highlighted in red, and these are the current steps being taken. When we have reached the final clustering state, what we can do is we can also go back in time to see what has happened over the different steps and to experience the clustering algorithm again, to replay basically what has happened. Of course, we're not just focusing on one clustering algorithm, but on many different cluster algorithms. And that's why in our software, we can easily compare the outcome of different clustering algorithms on the very same data set. So here you can see on the left-hand side, we have k-means, in the middle, we have the optics algorithm, and on the right-hand side, we have, for example, the dbScan clustering algorithm. And they all have different approaches how they work. And if we are looking at this result right now, we can easily see that, for example, k-means wasn't able to cluster the single letters and numbers. Same thing is true for optics. However, dbScan worked pretty well, so we were able to distinguish between the different letters and numbers. In our tool, since you can modify all the input parameters, what we can also do is we can take the very same algorithm and compare the outcome if we adjust input parameters. So for example, what happens to the value of epsilon, which is the minimal distance of my density function. And here you can see if the value is too high, what happens at the very end, that the 2 2s on the lower right corner are basically assigned to the very same cluster. So it doesn't work this well. However, for small epsilon, it works pretty well. So we can easily compare the different input parameters. Great. So this is basically the software. And I hope I convinced you that for lecturers, the software is pretty cool, because what we can easily do is we can easily create just our nice animations here. We can answer different questions. So if, for example, someone asks what happens if I'm increasing this epsilon value, I can easily show what happens. I can also load my own data sets into the tool to show different data distributions. So this works pretty well. And I assume that all lecturers are pretty happy working with the tool. However, what's the perspective of the students? So, for example, are they somehow profiting from this cool software device? And that is what we did in such an evaluation. So we want to investigate exactly this fact, whether the students also benefit from our software. And what we did in our evaluation, we decided on a certain design, which is a pre- and post-test design. So this means at the very beginning, a participant is working on an assignment. and the assignment includes some questions like in our exam. So for example, is it possible for a certain clustering algorithm to cluster this data distribution? And then you have to answer, yeah, it is possible, or no, it's not possible. Then after this pre-test, there's a studying phase. So people are able to prepare for a certain topic. And then there's a post-test. And this post-test is the very same question as being asked in the pre-test. So they're just repeating the very same assignment, but now they were prepared. Okay, this is basically a pre and post-test design. So in our evaluation, what we did, we took the participant, he had to work on our pre-test, and there we collected lots of information, like, for example, the accuracy, the completion time, and also how confident the participant was when answering the questions. Then there was the studying phase. And here we basically implemented a between group setting. So we split our participants in two groups. The first group, they prepared using EduClust for the post-test. And the other group, they prepared with common lecture material, like, for example, having access to slides, having access to some YouTube videos, having access to research papers, and so on and so forth. And at the very end, all of them, they took the very same post-test again. And there again, we collected all the information like accuracy, completion time, and confidence. So in our evaluation, we spent way more time. So it wasn't just one session. The evaluation took entirely 3 weeks. And here you can see how the different weeks were structured. So in the first week, we had a lecture on Mondays, and there we taught the students a certain topic, like, for example, about partition-based clustering. Then in the very same week, there were 2 tutorials, and that's where we basically split our participants. So in the first tutorial, people worked on a pre-test, and then they accessed the studying phase, and here they were working with EduClust in order to prepare for the post-test. Whereas in the other tutorial, people had the very same pre-test, but now they were studying using lecture material and then access the post-test. Okay, this was the first week. In the second week, we introduced a new topic. And for the studying phase, we were just switching the groups. Okay, so people working with EduClust had now to work with lecture material, and people working with lecture material had now to work with EduClust in order to prepare for the post-test. The third week was entirely different. So here we were teaching another topic, and in our tutorials, we were just asking questions how well the lecturer implemented the software during the lecture. Okay, what were our hypotheses? So our first hypothesis, and this one is pretty obvious, that if students are working on a pre and a post test, of course, performance is getting better because you have already seen the test, you had some time to prepare for the post test, and that's why we expect people being more accurate when working on the post test in comparison to the pre-test. And this is independent from the preparation method. The next hypothesis is that when people are working with EduClust, they are basically better than preparing with the teaching material, because in the EduClust software, you can easily just ask exactly these questions you would like to answer. So what happens if I have a different data distribution? You just load the data set and then you can look how it works. So we expect that people are better when studying with EduClust. And the last one is that people value the use of EduClust when it is implemented in the lecture from the professor or the lecturer. Okay, so these are our 3 hypotheses. So now let's have a look at the results. So we recruited 48 participants. It was basically the entire lecture. And now you can see what happened. So here in these different scatter plots, on the x-axis, we have the performance of the participants from the pre-test. On the y-axis, we have the performance of the participants from the post-test. Okay, so each data point is basically one participant, and we show their accuracy. And if a data point is above the diagonal, this means that the participant improved from the pre-test to the post-test. Okay, so this is how you can read the plots. The first scatter plot is about the first week, people preparing with lecture material. Second scatter plot, first week, people preparing with EduClust. This is the second week, people preparing with lecture material, and the second week, people preparing with EduClust, so a different topic. Okay, so now let's have a look on more aggregated information. And here you can see these are just some bar charts with arrows involved. And here you can easily see that, for example, in the very first week, which is the left-hand side, the bars are increasing if we split according to group. And here the group is basically the greenish color are people preparing with EduClust. This purple color is people preparing with the teaching material. And here you can easily see there's always an increase from the pre to the post test. So therefore, we can partially confirm our H1 hypothesis, which says that there is an increase. However, when looking at the second week, we can see that for the teaching material, there is no significant increase. And that's why we can only partially confirm this hypothesis and not entirely confirm the hypothesis. A possible reason could be that, for example, the studying period was a little bit too small or too short. And that's why people do not have this much time to prepare. And that's why there wasn't this much of an increase in performance. That's what we hypothesize. Okay, our second hypothesis was about whether people are better when preparing with EduClust in contrast to our teaching material. And unfortunately, when running the numbers, we cannot confirm this hypothesis. Okay, so unfortunately, people are not better, but that's also a good outcome, which means that our lecture material and teaching material is not this bad. Okay, but the cool thing is we do not have just the accuracy and the completion time. We have also some other measures, like, for example, the confidence. And when looking at the confidence, what we saw is basically that people are getting more confident when working with EduClust in contrast to people working with the teaching material. So when comparing the confidence from the pre-test with the confidence from the post-test, we can tell that when preparing with EduClust, people are more confident at the very end with their results in comparison to the teaching material. That's why, based on confidence, we can conclude that EduClust seems to outperform the teaching material. Okay, what about our third hypothesis? It was basically introducing EduClust to the lecture. And here we can see that all participants agreed or strongly agreed that EduClust helped them understanding a certain clustering algorithm when being introduced in the lecture. And also another question was basically that all of the participants agreed or strongly agreed that they will use the software to prepare for the final exam. And now, of course, you could argue this is just something that people cross because they want to finish the questionnaire and perhaps they like the lecture and that's why they tell, yeah, I will use the software, but I won't use it anyways. That's why we can easily just look at the numbers and we can check how our server logs look like. And before introducing the software, we have on average an access of 2 different IP addresses on our server. And these 2 IP addresses are basically the 2 people implementing the software and testing the software. After introducing the software, you can see that we have on average 13 different IP addresses accessing our EduClust server on a daily basis. And this is pretty cool, with a peak of 44 different IP addresses. And keep in mind, we only had 48 students. So nearly everyone was accessing our EduClust software in order to prepare for the exam. And this is pretty cool. Okay, so what are we doing now? We haven't finished with the software solution because now comes another big step because we want to transfer this 2-dimensional EduClust software into our virtual reality environment. And what we are doing here, we are trying to improve the teaching of clustering algorithm because now we have some more space to communicate something. So here in this case, for example, we can run the k-means algorithm. We can show some nice animations. We can adapt input parameters. We can play the software. We can assign the data points to the cluster centroids and so on and so forth. And in the very back, you can see that we can introduce more information, like, for example, a cluster quality measure, the silhouette coefficient. And here you can see that 2 data points seem to be not clustered this well, whereas the others are being clustered pretty well. Okay, so pretty nice improvement. Also, we can implement different, more complex algorithms, like, for example, the DB scan. Here you can see the color is basically reflecting the density distributions here. So we have 2 different clusters. The black data points are noise data points not belonging to a cluster. And we can just easily run the software here. And also on this clustering algorithm, we can run the silhouette coefficient and investigate how the final result looks like. And everything is really just in one space. This is pretty cool. And the last nice improvement is basically can really complex algorithms, like, for example, the DEN glue. Here you can see this is the EduClust software working with the Denklu algorithm. The algorithm basically calculates density distributions. And now you can decide what is the influence function of one single data point. So this is the EduClust software. The problem here is that we lose the information of the single data points. They can't be represented because otherwise they would be overplotting. In our VR environment, we can just show the data points. Now we just run the algorithm, select the one, like for example, here in our case, the Denklu algorithm. We have different input parameters we could adjust, like for example, the influence function, the cut level, whether it's a square wave or a Gaussian function. We can calculate the algorithm and now look at the very bottom and see the density distributions. So we have access to the data points and the density distributions, and all is in the very same space. We can change input parameters and then look at the final results again. And this is where we are currently working on, basically improving this VR environment to, for example, include social aspects like, for example, teamwork, with different kinds of functionalities that one student has access to steering input parameters, the other student can select the data which has to be analyzed, and so on and so forth. So it's an ongoing process which we are currently working on. And at the very end, of course, we want to evaluate the EduClust software versus our VRClust software and see where are the benefits. And this is basically where I want to conclude my talk. So thank you very much for your attention. I hope I wasn't running this much overtime. And of course, I'm happy to take your questions. Thank you.
Thank you. Yeah, so we have one question from Alessandra. Alessandra, do you want to talk?
Yeah, sure. Hi, hi, Johannes. Thank you for your talk and a very nice presentation. I enjoyed also all the demos, absolutely. Yeah, so I have a couple of questions and a remark. So the first question is the A/B testing. When you did the A/B testing, so if you could go to that slide, or anyway,
sure.
It doesn't matter. We know how it was. So basically, you said you first had them both in well, you separated them, some in EduClust, some in the other more traditional way, and then you swapped, right?
Yeah.
And that in principle is good because first of all you have better coverage of all the students, and second, you know, you can adjust for order of the systems. However, it does make a difference. It can be basically that you introduce a different bias, which is the order of the application. So the people that, for instance, saw EduClust first and then the lecture material might be biased in a different way and trained in a different way than the people that did the lecture material first and then EduClust. Yeah. So
may I comment?
Yeah. This is not basically the question, but if you have already the comment, that's probably the answer to the question. You see where I'm going with this.
Yeah, you're entirely correct. So there could be some ordering effects or some learning effects, but the reason was that we had to swap was basically, and because we want to investigate how the software works with different topics, and the topics entirely changed. And that's why we thought it's like a reset basically of the experience. And the second part, and this was the most problematic part, is that we have two different tutorial groups. And of course, if you have a between group setting, these subjective behavior comes into play. So it could be the case that, for example, all the bad students are basically in the first tutorial and all the good students are in the second tutorial. And that's why we had to swap. Otherwise, there would be a really huge influence of these subjective characteristics of the students.
Yes, but actually you had a high learning curve in the first week for the ones that were not using your system, and then in the second week the same people were learning much more. So it's based, maybe they're just the ones that learn a lot, almost regardless what you put them through, basically.
Yeah, could be the case, but also we think.
You see what I mean?
Yeah. But what we think, what happened here basically, that there isn't this much of an improvement in the second week, that the topic was too complex in order to prepare. And if you have just 15 minutes, the time was just too less for preparing for the post-test. And that's why we think it took, if you have a look at these two bars here, there's only a slight improve, although it's the very same test. And that's why we really think it happened because the studying period was too small, and that's why they.
Okay. I mean, normally, yeah, you need a bit more.
I needed to interrupt you because we are running out of time.
Sure.
Oh, I'm sorry.
So,
I'm sorry.
No,
Can I just make the one remark? You know, when you compared old-fashioned versus modern, that was kind of interesting because I think, yes, there's lots of progress, but if you look at the amount of distractions in the picture that you said, look how great it is now, the teacher was turned with a back to the students. The students were mainly watching their own screens, and basically they were ignoring each other.
Yeah, honestly, it was the picture was taken for the presentation, so it was an actual picture from our lecture. It was a little bit staged.
Okay, so
but only a little.
Just sorry about that because we are really running out of time. So just before I ask Oleg, you ask your question. Let me ask if we have any question on site. We want to have a balance between the on-site and in-person. Sorry, in-person and online. No? Okay, then Oleg, your question.
Yeah.
Oh, sorry about that. We have one on-site question.
Virtual reality is helping learners learn better or do better in the post-test. What are the affordances other than the experience in 3D, which we can also experience in an augmented reality environment?
Okay, so let me repeat the question because I had a hard time understanding the question. So I think you were asking for the benefits of the VR environment in contrast to our web application, right?
Yes, I'm just trying to understand why a virtual reality environment and why not an augmented reality environment, which also allows us to view something in a 3D space.
Yeah,
What are the affordances? Yes.
Yep. Entirely correct. So there are multiple reasons. So the first reason is, for example, that the augmented reality classes, they are just not this good in contrast to virtual reality classes. So for example, if you're looking at the resolution or the viewing angle, it's really restricted, even if you are taking actual current hardware, like for example, the HoloLens 2, only a restricted space with low resolution in order to show something really virtually in your current space. But our ideas where we want to go is basically that we want to collect all the students independent where they are currently located and put them in the very same room. And this doesn't work with augmented reality because there everyone is sitting at their desk. It looks entirely different. And then it's difficult to really visualize, okay, where is now the scatter plot located? Where are my other measures located? Like, for example, the silhouette coefficient, like the pseudocode, different other quality measures. And that's why we had to switch to this VR environment. With augmented reality, it simply doesn't work.
Okay, so thank you so much. Sorry about that, Oleg. Probably I cannot ask. I cannot have your question, but you probably can ask a question. I mean, asynchronously with our presenter. So thank you so much for the first presentation and
thanks for the questions.
Yeah, let's
thank you so much.
The next one. Yeah. Function execution log based judgment system for Arduino learning package.
Can you see? 15?
Yeah, we can see that. Do you want to make it as a presentation mode?
Yeah.
Or you want to use this?
Hello, this is Kang Bok-seo. The title of the paper I'm going to present today is Function Execution Log-Based Judgment System Learning Practice. My presentation is divided in section education. Recently, many schools are offering various Many schools are offering courses because programming has increased around the world. Increasing number of programming courses means that instructors who have to bear more. About this situation, various judgment and used it, and only support the programming language operated based on standard I/O. However, there are embedded system lectures dealing with hardware and software together, not just for learning software alone. And Arduino is widely being used in lectures because it is easy for configuring hardware. So embedded systems are coming up, but judgment system to support them currently. The reason is that it is difficult to implement the function that automatically tests hardware and software configuration. Below indicate the number of software courses in Korea announced by Kraus in 2020, and the right one indicates the usage status of programming lecture support system. The left one let us to know the number of schools that focus on software education is increasing. And the right one shows the current situation of systems supporting programming lectures, especially the graph on the right side. And there are few judgment systems that support embedded system lectures. Although the automatic judgment system have been mainly developed and used for language based on standard I/O, the development on the automatic judgment systems of other environments are taking places. The figure on the left below is the operation screen of the cat file created by the and compare one created by judgment and provide the developments on targeting query or web language as well as CAD are in progress. However, the research judgment system to embedded the system made it slow. The figure on the right below is operation screen of Arduino tutoring system announced in 2018. This system offers not the function of judgment, but the function for helping students to learn a basic concept of Arduino through the quiz made by instructors. As an automatic judgment system for embedded system does not exist until now, so I conducted a study on the automatic judgment system in this paper. Next. Overview. So the Arduino judgment system performs judgment based on Arduino source code and the hardware configuration file generated by fetching, not the actual hardware. First, the test cases required for judgment are created after the hardware configuration file written by the instructor and the source code are uploaded to the system. Hardware check conditions are automatically generated by extracting data from the hardware configuration file on the system. The test case that tests the source code is created by the instructor inputting the required input data, such as temperature and humidity. This hardware check condition and test cases test the hardware configuration file and the source code uploaded by student, and then provide them the result and feedback. This is how the system works. And I will give you more details about the hardware and source code part in the next page. First, the hardware configuration. The Arduino judgment system uses the hardware configuration file configured using fetching, not the actual hardware. Fetching in here is an open source software that supports the configuration of Arduino hardware on a PC. The hardware which is on the left side below is configured by fetching, and this data can be output in XML format. As you can see on the right side, the configured hardware list and connection information are all stored in XML format. So the system extracted this data and utilized them. When you look at the XML data, there are connector tag and net tag. The connector tag indicates the pins existing in each hardware, and connector pins in the net tag means that they are connected to each other. For example, tag indicates the A0 pin of the Arduino and the S pin of the light sensor are connected to each other. Next is hardware configuration testing. After outputting the hardware configured by fetching in XML format, the data is extracted and made hardware check condition. The hardware configuration test is conducted by dividing into hardware list and hardware connection. And the test is conducted by comparing the hardware list extracted from the XML file. The picture on the left side shows an example of a hardware list check condition. The test is conducted in this way: extract the hardware list from the hardware configuration file written by the instructor, make it a condition, compare with the student's one done through the same progress. If the hardware list test passes, the hardware connection test is performed. If not, the corresponding result is given to student. The hardware connection information is generated as a condition by extracting connection information from the XML file. The hardware names in each other net tag are extracted and created the connected hardware as a condition. Ground and power supply port are marked separately, and the other ports are only named. This is for including the cases in which students correctly configure hardware using different ports with the instructor. The test is conducted by comparing conditions generated in this way with the connection information extracted by student hardware configuration file. This page is about the function execution log. The output of the Arduino source code and the Arduino judgment system convert this output into a log format and then use it for judgment. The hardware used in Arduino is controlled by function in library provided by Arduino. Each function receives the connected Arduino port information and control command as a parameter and then operate the corresponding hardware. Function execution log means the output the combination of these functions and as a log format. As you can see on the picture below, the hardware port information is input as a parameter when digital read function is executed. And you can get the name of the hardware connected in this port and output it in the form of the number of 3 in the table. Next to the picture, the operation of Arduino source code is the output as a operating hardware. Then the Arduino judgment system converted this output into a log format and use it for judgment. I defined a new test case because the test cases used in existing judgment system were insufficient to test the Arduino software. Since Arduino has a characteristic of an embedded system, it was not enough to simply compare the output result. So I newly defined the 3 types of reflecting the characteristics of TTCN3. As you can see in the table below, these test cases are partial order between event, reaction time between event, hardware value variation, and Arduino software test is done with them. And 3 newly defined test cases are generated using function execution log. And event in a test case means one function execution log. The format of the test case is shown in the table below and is divided into event ordering and constraint. If the 2 parts are separated by colon, event will be put inside the angle bracket and the condition needed for the test are input further. Type 1 is an example of event ordering and refers to a test case, which can test that one LED can be turned on and off through the 2 digital light function. Example specify the range of delay as a constraint so that the range can be tested when there is a delay between digital light function. And constraint uses the numbers input the specific hardware are in ascending or descending order. I conducted an experiment applying the prototype of developed system to lectures. It was working with 15 students and 5 practice and only used the event ordering test cases. I was able to automatically grade the practices submitted by students through the system and collect the data, such as the number of submissions for each practice, the time spent until next submission, and frequent error made by students. In conclusion, this result of developing the automatic judgment system for Arduino and practice submitted by students were automatically graded through the system. I also considered the way to effectively instruct students using the collected data. Now I'm planning additional experiments by improving the insufficient part of Arduino judgment system and also do further research for increasing the usability of the system. This is the end of my presentation. Thank you for your patience.
Okay, thank you so much. And is there any question online or in the room? Okay, seeing none and hearing none, but I have several. So actually, can I ask one question regarding the what is the difference between the using test case for the program and then they get a result with this log-based evaluation? Because from what I saw here, it seems like very similar.
Can you repeat shortly, please?
Sorry.
Sorry. Can you repeat the question shortly?
So basically, my question is, so this research is about using log-based to do the judgment, to do the evaluation. But what is the difference between you use just like any program language, you use test cases and then send the test cases to the program and then get output, to see whether or not the program working fine. So what is the difference between this log-based judgment with the test case judgment?
The judgment system same. The other judgment system use log, but the other programming language, the other just software. And our judgment system is hardware test and software test. Set and another. Sorry, hardware data uses it and software test and software embedded software is embedded software execution environment are in different another source code, another software, and then we use hardware data and we conducted the hardware data in software execution. And then another judgment difference is hardware data uses the software execution environment. Environment make the software execution environment.
Yeah.
Sorry, I'm not good in English.
Yeah, I can understand. Yeah, that's a good. Yep. So do we have any question from online or in-person participant? If no, then we are about time. So thank you so much for the presentation. Our third speaker to present the cross-cutting support of making and explaining decisions in intelligent tutoring system using cognitive map of knowledge diagnosis. Let's welcome.
Do you see my presentation?
Yeah. Yes.
Hello, dear colleague. My talk today is about means of cross-cutting making and explaining discussion of intelligent tutoring system with cognitive map of knowledge diagnosis. Trust one of the mechanisms of efficiency for many interaction with artificial intelligence system. We know it by the name of explanation artificial intelligence. ITS-based learning require explaining its discussion sometime in the dialogue with the user. As a rule, the user is concerned about the question why, why the course, and why for me. Then interact with ITS. This primarily concerns the following aspects: demonstration learning material during an online course on learning program, grading simulation, summative task, recommendation content, explanation systems, statements in the dialogue model. All these problems are methodical. Logs of the interactions between learners and ITS and evolution of the article with the learning material is the basis of the idea discussion making. A prior data about the course, its structure and goals are invariant. Learner's goal and the learning trajectory in ITS are dynamics. They create digital learning footprint. In the process of the analyzing the discussion making conditions that have identified of following levels of data scale with respect to the which discussion making is carried out. Nano course material as a subject domain ontology. Micro, the level of learning units and the comparison of the learning topics. Meso, course level during a particular learning stage. And macro, learning program level. On the slide, you can see a diagram of the structural hierarchy of the training data aligned with the above scaled levels. Nano levels is the level of subject domain, learning material and activities, assessing knowledge and competency development for a specific learning unit. For this task, the digital footprint contains the data about frequency at time of access to the learning resource, students' successfuls, failures, and their stability. Then making pedagogical discussion. These data are mostly useful the helping the student to solving the current learning program and thoroughly are the little interest for the more complex discussion. Through the can serve and raw data. Micro level is the level of the learning user units and topics working together to build logic of presentation of learning material and help acquire the course material. In addition to the frequency and time of assess the course components, the data and this level capture the results of learning of knowledge and competency aspects. These components of learning digital footprint are important for intra-course discussion about individualization learning action. Meso level is a level of a course in a semester, including inter-course link and the semantic and competency aspect in the single ITS. This digital footprint data are necessary to manage the learning process to achieve normative and personal learning goals, including visualizing group dynamics. Macro level is a level of learning programs, academic majors, and learner learning goals. In generalized, the data from the previous levels and allows to work with the image of a graphic as while that can be overlaid with data about current learning, about the achievements to perform integrated assessment, comparison, selection, and goal settings. In additional, discussion makers levels and discussion making subject domain are allocated. Level of discussion making is operational, tactical, and strategical. Aspect of the subject domain is knowledge, competency, goals. The main receipts of the learning, but it can be both teacher and tutor. Which such a discipline of the learning situation, a number of problems arise the competition of discussion making by solver of ITS. What can serve as a basis to the complex user of the discussion making task parameters? How to take into account the relationship between the analysis levels and not lose the priority of the strategic goal? How to make a case to the discussion making by the system taking into account the recipient's role, and how to manage dialogue in a natural language flexibility. The basic technology of the discussion making can be scenarios, convolutional network, probabilistic method of cognitive visualization, among which in necessary to select graphics and histogram, clusters, dashboards, complex pictographics, for example, Chernow faces, and map of traits. When choosing the basis of the cognitive visualization, you can rely on structural or the functional approaches. Structural, the basis of the learning material topology on each level in the learning material. Functional, the basis of the activity-oriented approach to the learning process. Description is description. The dialectical unity will give the fullest basis for the making learning discussion and explaining them. Two problems areas with the choosing cognitive visualization tools. The take of unified graphic notation to working with the different scopes and aspects of the learning process analysis in ITS, and the transition between different notation with changing levels in the evident mapping is in the process of building maps in the studied object space, allowing the recording, structuring, generalization, cognition, and navigation. Benefits, it's a unified basis of the discussion making, possibility of overlay the digital learning footprint data, and possibility to track the learning trajectory on the learning. Cognitive map of knowledge diagnosis is cognitive map showing the result of the information generalization stage after synthesis or metric concentration. In ITS, automatically preparing information about the learning process to knowledge in order to simplify expert analysis of the learning situation and generate the determine an effective response to students' actions. This mechanism is implementation in the experimental ICU ITS. CMKD components is generalized learning trajectory in the form of a thick arrow. Learning unit in the course, located object inside the circle. Semantic relationship between units. Alternative learning material located object outside the circle. Executed from the course material based on the result of individualization. Also, various font outlines, line thickness and colors, and form shapes and used to encoding features. A heat map of the also supervised to the map. Red is the minimum value of the attribute. Green is the largest value. White is the unsoundly zoned, and gray is the absence of the attribute element of the current aspect. In the slide show the relationship of maps for vertical scopes levels. Such a mapping is possible for the learner, a group of learners, or all the learners in a particular program in year. Consider as an example the discipline simulation modeling. This CMKD is shown on the map on the left. This is a micro level for a set of discipline for a semester. A map is shown the center. This is a meso level, and macro level for the master's degree curriculum. The map is shown on the right. For horizontal navigation between maps, it is necessary to switch between aspects of analysis. At the same time, the map remains unchanged, but various data from the digital education footprint are overlaid on it. As example, the data of the visualization stand taken, which are superimposed on the CMKD of the discipline simulation modeling. The map is shown the left in the competence aspect, in the center the knowledge aspect, and the right in the goals aspect. The slide shows the diagram for cross-cutting discussion-making support. Easy switch between scope and aspects of analysis given a single coordinate basis for discussion-making. Also, each map allows switching between the discussion-making levels that are important for the recipient of the current learning situation. Let's choose the master's degree curriculum informatics and computing in Siberia Federal University to illustrate this approach. The 9 courses to gather a digital learning footprint. 3 groups of 8 students used ITS-ISO for survey learning materials, formative and summative assessments, dialogue with the system. For each student, we recorded surveys, including personal goals, learning trajectory in the individual course in the ITS, summative assessment result, about 800 reports in average, 1,350 answers per each student, and competency profile and dialogue trajectory. Evaluation of the level of trust of the ITS explanations. Synthesis CMKD on overlaying them with the data from digital learning footprint. Map analysis during validation of ITS hypothesis. ITS action and dialogue explanation, showing implicit interactive CMKD on the current level. Buttons to get natural language explanations of a particular part of its discussion using in the cross-cutting approach. Concentrating attention on the ITS arguments can be done by focus on some map elements and removing secondary data. On the slide show an example of a variant simplified the map. The generalized realization of the assessment of the increase in the levels of confidence in ITS answers are shown in this slide. Students from the 2 experimental groups shown a similar result and trust ITS recommendation more than those who had not seen CMKD. The difference was almost to 20%. Recommendations for using the course cross-cutting approach in ITS. Take into account semantic structure of the learning material and a learner's goals and expression. Be careful aggregating data of different students in personalized course because the learning conditions are not the same. To better explain the learning situation, the action-based approach may be preferable to the structural approach. We have considered a structural approach based on the CMKD, but you can combine it with the functional one. It is based on UGVA graphic notation, a variant of Chernoff phases, for complex visualization and comparison of multi-parametrical objects. The figure shows the image of the curriculum and the overlay of data from the educational footprint for 2 students in competence aspects. Let's introduce UGV annotation in the cross-cutting approach. Then, in order to support discussion making and the explanation, modal switching between the structural and functional approach can be carried out. We are currently active working in the following areas: extending the list of courses and modules for the complex empirical study. Integration functional and structural approach into a single ITS. Using the ITS ISO to manage the quality of the learning process on the department and curricular levels. In conclusion, cross-cutting approach to visualizing discussion making and explaining discussion by ITS based on the cognitive map of knowledge diagnosis had a stable positive effect on the result of the learning process. The trust on the IDS discussion can be enhanced by using different methods of the cognitive visualization. You can read more about this research in the following works. Thank you for your time.
Thank you so much for the presentation. Is there any question in the room and online? Yes, we have one question. Oh, sorry, no, actually, we don't have a question online. I just saw a big hand. Oh, yeah. Is there any question in the room or online for the presenter? Hearing none and seeing none, then I do have a question. Actually, I do have a couple of questions, but okay, let me ask. Just want to know about the drawing you showed, the cognitive mapping of knowledge diagnosis. So how at the very beginning, how the connection between different elements are established? Is that done by human beings or is that done by a system?
Thank you. Then courses in construction. Teacher is connect all parts of our materials, and on next stage, the map is synthesis automatically by these links and another parameters in the course.
Okay, that's good. So that is also how the colors coming from. Is that right?
Colors is automatically colored on some part of the map by data in the digital footprint. It's a result of task and some data in user model.
Okay. Okay. Thank you so much. Any last question for the presenter in person, in the room, online? No, not seeing anyone. So thank you so much for the presentation. Covering possible reasoning errors for intelligent tutoring system, order of expression evaluation case.
Yeah, can you see my screen?
Yes.
Yeah, so today I will speak about one step in our work on making dialogue with students about their errors. What was our motivation for this work? When students in ITS solve complex problems, not all errors are identified from their answers. There are observable errors and there are real reasoning errors that the students do while solving the problem. And just finding the precise cause will help customizing feedback and tracking student problems. For example, when the student solve a simple problem as determining an order of expression evaluation and consider this expression and the student makes an error by trying to evaluate the ampersand operator first. The observable error is that the student evaluated first the operator with lower precedence. However, there are 18 possible reasoning errors that can lead starting from that the student doesn't just know that the ampersand uses two operands, or the student can analyze the associativity before the analyzing precedence, or the student can not know the factual precedences of the two operators involved, and so on. There are many ways to come to the same observable wrong answers. And without identifying them, we cannot know what caused this error, and we cannot fix the student misunderstanding. It also interferes with. So our goal is to systematically model the line of reasoning necessary to get answers and build error sets that coverage all possible answers, all possible wrong ways the student can make error. To do this, we need to model reasoning, how students should do, what students should think to come to the correct answer. Reasoning can be modeled using several kinds of steps. Questions that should be answered with different movement during the questions. Actions like finding some object, calculating something, and so on. Actions have specific types of error tied to them. Branching, which splits the line of thought in several chained lines. If the question is a yes or no question, the conclusions from different lines can be aggregated using logical and or not or operators. And iterating objects satisfying certain criteria and performing some actions for all of the iterated objects. Here is an example of one line of reasoning concerning one right operand fully evaluated. We choose the expression order of evaluation because while this task seems easy and it learns during math and programming courses, it's actually a very complex reasoning task that includes a lot of concepts, a complex decision tree forming. You can see questions as here the students have to answer actions by finding new and introducing new objects and variable into all those reasoning. Branching for taking three independent things about parentheses that has no direct order. And conclusions that the operator can be evaluated according to this branch or cannot be evaluated. And there are those lines that represent particular error during actions and prerequisite knowledge. So analyzing this knowledge graph, we were able to identify and find kinds of atomic reasoning errors. Choosing a wrong first step, starting wrongly, answering a question wrongly. So this is something that happens inside a particular node of this graph. Third kind of error is drawing wrong conclusions from the correct answer. First and third kind of error is moving wrongly. It's an edge error. The student can use this graph in different order. And also there are missing questions like missing branch or missing an object. Second question errors deal only with wrong object selected, but missing a correct object is a separate kind of error. And wrong aggregation, for example, the student must aggregate answers by and, but they actually aggregate them using or instead of and. For each possible error, we can find a templated message that can be enhanced with the data about a particular reasoning node. The only exception is errors regarding actions or iterations, because they depend on the kind of action. So for actions and iteration, we have special way to specify the error. For example, if the user have to find the right clauses and using the operand, the possible errors is that the operand is not 2x right, but to the left, that the operand is too far, not the closest, and the operand is not unused. It is already used or it isn't evaluated yet. For those errors are checked. So, for example, for this line of reasoning containing one branch, that it is possible to find errors of 4 kinds. For example, the learner attempts to find the left operand without verifying that the operator really needs the left operand. Answering questions wrongly, answering questions in the wrong order, and missing something. Totally, these lines give more than 50 possible reasoning errors. The full list is provided in the paper. For branching and iteration, the errors of the 4 a fifth type are possible: missing branches for operands that are independent of all other errors, and aggregating wrongly, either not by the end, but by or. For example, all operands must be evaluated to allow the evaluation of this operator, but the student thinks that if only one of its operand is evaluated, this operator also should be evaluated. So for the expression order of evaluation, the general schema of the subject domain contains 4 branches with 38 nodes representing reasoning steps. We found 124 reasoning errors for these nodes. Actually, for type 3 errors that represent choosing the wrong next node, it seems that the number of possible errors may be even bigger, but it is actually controlled because some steps introduce new variables, and you can't ask a question containing new variable z until you identify that. This limits the number of possible errors, while it is still not small. How to evaluate the number of reasoning small errors? It's not easy to evaluate for humans because we have a lot of small errors, some of which are likely and some of which are not quite likely, but we want a complete coverage of the subject domain. We asked it for experts who were teachers in CS0 courses and taught this topic to undergraduate students of our university. For the question, does this error set cover all possible errors? 2 experts agreed that it covers all, and 2 selected options the most of the errors. However, when asked to identify the missing error, none of the experts weren't able to name any errors that our method missed. So actually, they were just unsure if those are all of the errors or if something else it can be. 2 experts found the level of detail sufficient, something that they are too detailed than necessary. The experts also provided their opinion of which errors were most frequent and which can be useful for defining better support in ITS and which errors weren't. So later we are going to formalize these descriptions of line of reasoning that I showed to you as a graph and developing program module for generating all those errors. And this really allows us to generate dialogue with the student about their error, so-called leading questions or follow-up questions. So instead of just telling, oh, you are wrong in this, the system can start question student about the information necessary to solve the task until they understand what they did wrong. And we also consider using this method in other well-defined areas like English, other than programming, for example, what order in English sentences. So what we came, in ITS, there is a lot of topics covered in ITS literature, but the idea of systematically building all sets of possible errors are not well covered up to now. However, this is a step towards modeling how students should reason to come to the answer and generating dialogue with the user without teacher participation for those who cannot understand the complex messages about big errors. And so it's a way to better learning. Because in my teaching experience, I found that asking students small questions is often better than just telling them what they did wrong, because it makes them think, makes them retrieve information, and it stimulates activity. It also may stimulate to students to respect the system more because it is capable of dialogue on its own without teaching. Thank you for your attention. I'll be glad to answer your question.
Okay, thank you so much for the presentation. Any question in the room or online for the presenter? Anyone? If not, actually I have many, but I think the most two important question I have. The first one is the line of reasoning. How much time or how a teacher will put the efforts to create this line for one, one possibility of one possibility. How much time they will or effort they will need to put?
I won't hide it. Designing this lines of reasoning and the overall decision tree for the task is not an easy thing because it is tied with logical programming. In fact, it's a way of programming and what is particularly interesting, it requires a certain way of thought. Even I had to learn to do it, and even my co-workers helped me to find errors in it. However, those lines of reasoning can be used for many tasks. We are now developing algorithms and code that allows building entire ITS based on those lines of reasoning. And this ITS can solve the task and make hints. It also implies using generated questions because it can solve any generated questions. I will be presented at EduClust about our atoms at question generation. It also able to identify systematic errors, semantic errors, and provide meaningful feedback. And it is able to generate the sets of follow-up questions. For example, we tried to build the set of follow-up questions manually for this line of reasoning. Our first attempt was manual and it turned awful. It was a lot worse than created this line of reasoning. So while it's not easy, it allows a lot of answers and it is beneficial once it's done. And it also must be done once per topic only.
Yeah, sounds good. So any question in person or online? If not, actually, I want to ask one more question. So we see at the end there are 124 possible reasons for that error, and I wonder how this kind of output can help teachers to provide or help a system to provide a personalized or Comparative tutoring service for students.
This list of errors is more for the ITS than for the teachers because teachers are intrinsically more concerned with typical errors, so that they can help students most of the time. No one will remember 100 of possible errors to help everyone. It's just, you can get it. That's too bad. But when we're designing an ITS, it can take care of all the possible errors. And then it will be able to advise any kind of student over any problems. I actually had an interesting experience with foreign exchange students who had a lot of problems with the language and learning, and they were not able to learn at all for half of a year. And then they worked with the ITS and it started. They didn't even learn how to use the ITS. And then once I showed them, they started to get hints. And over time, they describe it very simple things, but they at least learned them.
Okay.
This is systematic, and with question generation, it can be done as long as the student needs. That's, I think, is the benefit of ITS. It can take this load of the teacher. The teacher doesn't need to understand those errors.
Okay, thank you so much. Okay, so thank you so much. Let's welcome our next speaker, Rita Kuom. She is presenting the next paper that is Load. A Moodle plugin helps to find the relations among the learning objects. Let's welcome her.
Hello, everyone. I'm Rita, and today I will present the paper, Load, a Moodle plugin that helps to find the relations among learning objects. And so I believe all of you have used the learning management system, especially after COVID. So the learning management system can help teachers deliver the teaching content to the students, and also students can try to have some communication with no matter the teachers or with their classmates in the system. So in this research,
have you shared your screen yet?
Maybe not. I'm sorry. Give me a second. So, let me do this one.
One Maiga, you can see it on the other computer.
Yeah. Apologize.
Maybe if you F5.
No.
No. No, you need to change to the beginner. No.
Okay, so I think that should be good enough. Okay, so so in the learning management system, we use it to help teacher and the students. But what we want to do in this research is how to integrate the learning analytics in the learning management system. So the learning analytics are usually used to like predict students' performance. So like the retention and the dropout rate in the course. So in our past study, what we did is we built a behavior analytics Moodle plugin, and this system is helping us to build a graph-based student behavior presentation and analysis tools. And if you are interested, you can go to this website, because you are able to download the plugin and install in your Moodle system. So the function of this tool is able to organize the learning resource and activities in based on the sessions created by the teachers. So for example, you can find out in this system, if the teachers already set up two sessions, topic 1 and topic 2, and the topic 1 has 2 learning materials and 1 assignment. In the topic 2, there are 2 reading activities. Then we are able to organize all these learning activities and resource into a tree structure. So after this part, we will try to track the students' behavior when they visit all these resources, and we are able to build a student behavior graph. So you can find out there are two students examples. Amy prefers to check the content of the assignment first. So he starts visiting the assignment, and then they will go to the 2 materials. Then that's the topic 1. And then they will go to the topic 2 materials. But Betty prefers to read the materials. After she feels that all the content are familiar, then she will go to the assignment. So you will find out based on these 2 behavior, you will compose 2 different learning graphs. So then in this system, we are able to see the students' learning behavior in the, so you can find out this graph is the real system snapshot. You are able to see all the tracks. And the good part is you are able to see the activity coverage. And this kind of coverage can help the teachers to compare the students' behavior. So for example, like this one, you can see we try to activate 2 students' behavior. So you will find out some activities are covered by both students. So then we also use this system to help us to cluster students. So we would like to see what kind of students should be in the same group based on their behavior. So what we did is we try to find the centroid of the students' behavior graph. So you can find out even though both Amy and Betty visit all the learning behaviors, learning resource on this graph, but they will get different centroid because we use the centroid decomposition method to find the centroid. And then later, we are able to, so you can find out the triangles, actually these are the centroid. And then we will try to find which students are in the same group. And so for teachers, they are able to see the common patterns in the same group. So you can find out the ages on the graph. These are the common patterns or common paths between the students in the same group. And they are also able to add some notes for these groups. So in this case, the teachers can make, for example, this group is the students who has low performance, and also they didn't read the materials. So in this case, we are able to give proper feedback to the students. Okay. So this Moodle plugin we presented actually is also in ITS last year. We do find out there are some issues because currently we build a graph based on the content structure. So in this case, if the teacher didn't set up any sessions, so that means that's a flat map. Or maybe the teacher, there are some kind of learning resource in two different topics, but they are very close connected. Then we are unable to know this situation. So what we want to do is we want to analyze the content in the learning materials or learning resource, and we will try to generate this kind of learning objective graph to the teachers. So in this case, the teacher can have some kind of idea, okay, what kind of relations between the learning materials they have, and maybe they can do some kind of adjustment. So how to build this kind of recommendation for the learning object graph? What we need to know is we need to know how to find the similarity between two learning objects. So what we did is we tried to build a word in a sentence natural language processing similarity service. And of course, you can also use our service in the WSNLT vip.research.ca, and we are welcome you to use our service, and maybe also can give us some feedback. So what we did is we tried to use the WordNet as the knowledge graph, and then we will use this knowledge graph to find the similarity. So let's take a look at this example. So the WordNet, maybe some of you have heard about it, but if you have heard about that, this is a kind of dictionary, but it's not a real dictionary. It's not the traditional dictionary. It will try to put it has a lot of syntax. The syntax is a group of words that is from the same lexical categories. So then it also has some kind of relations. There are 6 relations defined in the WordNet. So currently on this graph, I try to use two common relations, like hypernet and hyperlinks. So for example, like the relationship between dog and canon is the hypernet relation, because dog is a type of canon, and then the corgi is a type of dog. So in this case, they have the hyperlinks relations. So then we can use this kind of graph to find the similarity. So we can find out the dog and the corgi, they just need to cross one edge from one node, from one syntax node to another one. So each has a closer distance between these two concepts. So we will find out the similarity, we can say is 0.5. And the dog and bear, actually you need to cross 3 edges to find each other. So in this case, they have less similarity. So the similarity based on calculation is 0.25. So we use this method to find the word similarity. But usually in the teaching materials or the learning activities, we will have the sentences or paragraphs. So what we did is we will find the word similarity first, and then we will use the Moncrief's assignment algorithm to find the pairing of the word similarity. And then we will try to find the maximum similarity of these two sentences. So for example, like in this example, you can find out the first sentence is constant field, and the second sentence is static field and methods. So we try to remove the some conjunction words like and maybe we will also remove like the and a, this kind of words. Then we will build a similarity matrix like what we have here. So then we will try to use the Moodle assignment algorithm. So we will try to find like field and the field, because they are the same words. So we have the highest similarity. So we will find this this pairing first. And then later we will try to find out what is the pairing for the constants. So comparing to method and static, we will find out method has a higher similarity. In this case, we will find these two pairings. And because usually maybe we won't have the even number of words in these two sentences. So for static, we will just consider the similarity is 0. And after we calculate all the similarities, then we will start calculate the average similarity of the sentence. So in this case, we will add all the similarities and divide it to the maximum number of the words in the sentence. Then we will get this similarity. And when we are working, so this is sentence similarity calculation. If we want to do the paragraph similarity calculation, then we will try to find the similarity of the sentence first, and using the same algorithm to evaluate the similarity in the paragraph. Okay. So we use this method to build the Lord Moodle plugin. So we already upload this plugin on the Moodle add-on environment. So if you want, you can go to our website first, and it will navigate you to the Moodle add-on system, and you are able to download freely. And after you install this plugin in the Moodle, you are able to find the block, Lord block here, and you are able to click view graph, and you can see this is the graph built by the system automatically. So if you find out there's a thicker edge, that means it has a higher similarity between these two learning materials. And then if you want to see how we calculate the similarity, you just need to click one node first and click the second node. Then we will be able to see the similarity here. So we just tell you how do we calculate all the processes. And of course, for the teachers, they are able to go back to this graph, and they are able to adjust the node position based on their evaluation. So this is the system we build. Okay, so let's go to the conclusion. First of all, we build a word and a sentence natural language processing similarity service. It can help us to calculate the similarity between words, sentence according to the wordnet as a knowledge base. So this service is used in the Lord Moodle plugin, and the Lord Moodle plugin can help the behavior analytics Moodle plugin to retrieve the information in the learning objects in the Moodle, and then try to find the similarity between the object and build these learning object graphs. So currently we are evaluating our systems. So we invited two professors in the North America who are teaching the STEM courses, and one professor in Asia who is teaching the social science course. So we would like to ask the professors, first of all, we get the agreement to collect their students' past behavior. And then we would like to ask the professor to retrieve the data from their past courses and generate a graph. And we would like to ask the professor to compare the graph they created, the graph the system created, and they are able to adjust the graph by according to their judgments. So what we will do is we will try to compare the graph generated by the system and the graph adjusted by the professors. And the next part is we want to see if our Moodle plugin for the behavior analytics is properly classified students into right groups. So we will also ask the professors to check the students group properly or not. And the teachers are able to put the students into different groups based on their judgments. And we will also compare these two results. So this is our research. So any questions?
Any questions? Thank you so much. And any question in the room or online? I saw one question online and one question in person here. So this time let Oleg first, because Oleg was missing his chance at the first presentation. Oleg.
Yeah, thanks. I have a few short questions. First, you used WordNet. Did you use use a word sense ambiguation and synsets, or did you use just all the synset and the best synset of the word you used?
We use all the things. We use the non-synset mainly, noun and adjective. Yeah, so we use almost all the synsets.
Oh, yeah, because you might want to evaluate it better, because it is well known that in WordNet the system of hypernyms and hyponyms is not perfect, is very far from perfect, and it can give very strange synsets. Especially you can just risk interpreting the word wrongly and missing connection. I published some research on this some time ago, and just also, again, speaking more generally, this system can be good in linking several activities on the same topic together, because they will naturally use the same words, but they will not link semantically linked parts which use different words, because WordNet doesn't know how different learning topics are tied together. Did you have any plans for considering semantic similarity of topics and so on? Maybe some Wikidata, ontologies of subject domains, and other semantic information, not just words.
I think that's a very good recommendation, because currently because you can find out in our past study, we try to rely on the teachers organization, and in this study we are completely rely on the WordNet, how they like our similarity process. So I think what we can do next is we can try to integrate these two, because usually the teachers are able to have some kind of if they organize the content, usually they have some kind of ontology. These kind of tree structures, and we would like to see if we are able to integrate it more properly. Yeah.
Yeah, thank you.
Well,
Thank you. And then in-person question.
Yes, interesting presentation.
Thank you.
In your objectives, you say one of the objectives is to detect the dropout. Yes, this is very important. But how can you detect the dropout with your approach? Or maybe it's a preliminary work.
So for this one, first of all, what we can do is we can see, because we are collecting the past students' behavior. So what we want to do is we want to see the students' behavior who have a lower academic performance, then because usually for students who drop out, based on my experience, usually is they fail in the class or they don't have interest in the class. So for the people who fail in the class, they just drop out. They just didn't do anything in maybe like in the middle of semester. So what we can do is we are able to, based on our behavior analysis, we can see maybe this kind of this group of students, they didn't go to the teaching material very often, or maybe they just missed some of the materials. Then in this case, we are able to pull out this kind of data and gives the teacher some kind of warning. Yeah. So I think for this part, we just try to see if we are able to find out the students who drop out early or in the later, and what is their pattern according to our past students' behavior. And we would like to use the similar way to detect the future students. So when they are enrolling in the future classes, and if we find out they have the similar patterns, and then we would like to send the warning to the teachers, so the teachers can do the next stage.
Mm-hmm.
Yeah,
because it could be interesting to associate with a graph something which is motivation, the level of motivation,
yes,
which can be reduced because maybe of the difficulty of the graph, of the nodes in the graph, or something like that. But you address a very important topic,
mm-hmm,
which is a dropout
Yeah.
Why there is dropout? Normally, sometimes it's about 80%, 85% dropout. And this is important to detect.
Yeah, so I think like this one we are able to see if we find out like if the red one is students who have high performance and if the green one is students maybe drop out early, you can try to compare what's going on based on their behavior. Because if we just try to see the log, you just see a lot of numbers, or maybe you can give some statistics. But in the graph, maybe the human being are able to see some different patterns. Yeah, so that's my point of view.
Thank you so much, because we are running out of time. So if there is any question, you can contact to our authors in person or online. So once again, thank you so much for everyone's presentation today. And so this is the end of our first session in hybrid mode of ITS, and I think it is quite successful, and we are also a little bit 5 minutes late, but that is to be okay. So thank you, everyone.